The NASA ESA Hubble Space Telescope has recently revealed magnificent sections of the Veil Nebula, the shattered remains of a supernova that exploded some 5,000 to 10,000 years ago. The new Hubble images provide beautiful views of the delicate wispy structure resulting from this cosmic cataclysm.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope, travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Welcome to the Hubblecast. Today, we'll take a closer look at one of the most violent events in the universe, a supernova explosion. It is the debris from one of these cosmic explosions that we can see with unprecedented detail in these brand new images from the Hubble Space Telescope. Although we don't usually think about it, the stars twinkling in the night sky do not shine forever. How long a star lives depends on how big and heavy it is. The bigger a star, the shorter its life. Now, a star shines because of the nuclear fire burning at its center. And when a star significantly larger than our Sun runs out of fuel for this fire, it first collapses and then blows itself apart in a gigantic explosion that we call a supernova. A supernova releases so much light that it can outshine all of the stars of an entire galaxy put together. The explosion sweeps out a huge bubble in its surroundings, and at the fringe of this bubble we find the actual debris from the star as well as the material that has been swept up by the blast wave. It is this glowing, brightly colored shell of gas that we see as a nebula, and that astronomers refer to as a supernova remnant. Now, the remnant can remain visible for a very long time after the actual explosion itself has faded away.
Astronomers have pointed Hubble towards the constellation of Cygnus to observe the Veil Nebula in the wing of the Swan. Located at a distance of 1,500 light-years from Earth, the Veil Nebula, which is also known as Cygnus Loop, is one of the most spectacular supernova remnants in the sky. The entire shell spans some 3 degrees, corresponding to about 6 full moons. One of the most remarkable parts of the remnant is the so-called Witch's Broom Nebula. The bright blue star, dubbed 52 Cygni, is unrelated to the supernova explosion. It can be observed with the naked eye on a clear summer's night. The small regions captured in the new Hubble images provide stunning close-ups of the veil. Fascinating smoke-like wisps of gas are all that remain visible of what was once a Milky Way star.
Scientists estimate that the supernova explosion occurred some 5,000 to 10,000 years ago. Now, what that means is that it could have been witnessed and recorded by ancient civilizations. What they would have seen is a star increasing its brightness roughly to the brightness of the crescent moon.
The intertwined rope-like filaments of gas in the Veil Nebula result from the enormous energy released as the fast-moving debris from the supernova explosion plows into the surroundings and creates a shock front. This shock, driven by debris moving at 600,000 kilometers per hour, heats the gas to millions of degrees. It is the subsequent cooling of this material that produces the brilliantly colored glows. The Hubble images of the Veil Nebula are striking examples of how processes that take place hundreds of light-years away can sometimes resemble effects we see around us in our daily lives. There are similarities with the patterns formed by the interplay of light and shadow on the bottom of a swimming pool, rising smoke, or wispy cirrus clouds.
So why are astronomers interested in studying supernovae and their remnants? The reason is that they are extremely important for understanding the history of our own Milky Way. Although only a few stars per century in our galaxy end their lives in this spectacular way, These explosions are more or less directly responsible for creating all the elements in our universe that are heavier than iron. For example, all the copper, mercury, gold, iodine and lead that we see on Earth around us here today were forged in these violent explosions billions of years ago. The expanding shells of the supernova remnants eventually mixed with other material in the Milky Way, and this became the raw material for the next generation of stars and planets, including our own solar system. So the chemical elements that constitute the planets, the Earth, the plants and animals around us, and indeed our very cells, were built deep inside ancient stars and in supernova explosions. So the green in the grass and the red of our blood are in fact the colors of stardust. This is Dr. J signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.